In the first part of example 3, we have a few different systems to solve by graphing. Let's try the first one. In A, we have two lines. The first one is y is equal to 2x. So the y-intercept for this one is at 0, 0. There isn't one. If you want to put a plus 0 here, that's fine. And then the slope is 2. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1. And we could also go down 2, left 1, down 2, left 1, and so on. So what we'll do now is we'll just graph this line, try to do a very, very good job here with your precision. If you're not very precise, then the intersection point, which is what we're looking for, is not going to be precise either. So that one's in green. Let's try the next one in a different color. We'll go with purple here. So we've got y is equal to negative 2x plus 4. That line has a y-intercept of positive 4 right here. And then the slope is negative 2, so it's going to be down 2, right 1, down 2, right 1, down 2, right 1. And with these I kind of stop after I find the intersection. It's nice to be able to draw the line all the way across, but we really have found what we need for this one, and that is this point right here. So that intersection point is at 1, 2. 1, 2 is the solution to this. We want to check it with each one of the original equations though. So let's check it with the first one. And we'll do 2, which is y, is equal to 2 times x, which we think is 1. And 2 is equal to 2 times 1, so that one is checked. The next one is going to be 2, that's the y, is equal to negative 2 times 1 plus 4. So 2 is equal to negative 2 plus 4, and we still get 2 is equal to 2 in this case. As long as each one of these is true, we're good to go. Let's try the next one, B. So we've got y is equal to x plus 4. That has a y-intercept right here of 4. The slope is 1, so that's going to be up 1, right 1, or down 1, left 1. And you could keep going. We can even skip some boxes here. Down 3, left 3, same slope. We know it's positive, and this slope is definitely positive. And a slope of 1 or negative 1 is going to go right through the diagonal of each one of these. So there we go. There's the first one. And the second one here is we're going to have to do a little bit of work here. The y is not solved for, so we're going to subtract 3x here first. And we'll have y is equal to negative 3x minus 2. Now we're in slope-intercept form. We can identify the y-intercept as being negative 2 and the slope as being negative 3 or down 3, right 1. Or we could go up 3, left 1, up 3, left 1, and so on. So let's go ahead and draw these. I think we can see where that intersection point is here. And we'll make that line right there. Now this one seems kind of interesting. It seems like this point is right in the middle of one of those blocks, one of those rectangles. So it would be left by 1.5 or negative 1.5. You could also make that negative 1.5 or negative 3/2. That's fine. Oops, I shouldn't have closed that in. You know what, I'm just going to rewrite that whole thing here. If this was in pencil, I would definitely erase it. But I am writing in Sharpie here, so I'm kind of stuck with just scratching that off. Then it's up 2.5, or 2.5. So you're seeing one of the limitations of graphing, and that is it's not incredibly precise if the lines don't intersect on a grid line. But let's see if this works. So we've got 2.5 here for y. We're going to check it with each one of these equations by substituting back in. And we've got negative 1.5 plus 4. So 2.5 is equal to negative 1.5, and 4 is 2.5. So this one is checked. The next one is 3. We always go back to the original. 3 times negative 1.5, so I'm just using this original one in the black ink here, plus 2.5 should be negative 2. Well, 3 times negative 1.5 is negative 4.5. And negative 4.5 and 2.5 is definitely negative 2. So this one does check. We've actually found the correct ordered pair here. We're going to do a couple more. You'll have to watch another video for examples E through H, but let's try these ones on for size. Alright, so we've got y is equal to x minus 4. That one's already in slope-intercept form. So we're down here at 4. We're going to go up 1, right 1, and so on. So we could skip a few blocks if we wanted to. Graph a little bit faster. So let's see. We're just going to connect these guys up. I think this ought to do it. There we go. So that's the first one. And then the second one here, y is equal to negative x. If you want to put a plus 0 there, that'll help remind you that the y-intercept is 0. The slope is negative 1, and we've actually intersected that line right there. So I'm just going to go ahead and draw this. You still want to do a good job being as accurate as you can, but what we're looking here with that system of equations is that intersection point. So the intersection point is right here at 2, negative 2. So let's see if it works. Let's check it. For the first one, we've got y, which is negative 2, is equal to 2 minus 4. And negative 2 is equal to, well, 2 minus 4 is negative 2. So that one's good. Let's try the next one. Y, which is negative 2, is equal to the opposite of x, which we think is positive 2. Well, negative 2 is equal to negative 2 is also checked. We've got one more here, so we'll do part D. We'll do y is equal to negative x plus 3. Y-intercept would be 3. Slope is negative 1, so that's going to be down 1, right 1. And we could even skip a few boxes here. And then we could go in this direction, up 2, left 2, or up 1, left 1 is fine. And we definitely want to make sure that that has a negative slope on it. It does. And we'll try the next one, y is equal to x plus 1. That's a y-intercept of 1 with a slope of 1. So when we graph that, it's going to look just a little bit like this. Now these grid lines are off a little bit. Ideally, these two slopes of negative 1 and 1 would meet perpendicularly, but these rectangles are a little bit off. Let's double check this intersection point though of 1, 2. That's going to be the solution. I should have boxed that one in over there. So 1, 2 here. Let's check the first one together. So let's do y, which is 2, is equal to negative 1 plus 3. Well, negative 1 plus 3 is 2, so that one's checked. And the next one here is 2 is equal to 1 plus 1, if we just use our substitution for x and y here. And 2 is equal to 1 plus 1, so this one is checked as well.